This tutorial is for 5th grade Module 1, Lesson 2. In this lesson, we're looking at the pattern that appears when we multiply by powers of 10. So to start, I have this problem, 19,340 times 10. If I think about the place value work we did in previous lessons, we know that when we multiply numbers by 10, each digit shifts one place value to the left. So the answer to this question would be 193,400. And as I can see, each digit shifted one place value to the left compared to the original number. As I drop down to the next problem, I'm starting with the same number. This time I'm multiplying it by 100. Again, if I can visualize that place value chart, I know that each digit now moved 2 places to the left. So the answer to this problem is 1,934,000. And in the third problem, again, I'm starting with the same number, thinking about my place value chart. When I multiply by 1,000, each digit moves 3 places to the left. Which gives me a final answer of 19,340,000. Like I said, the goal of the lesson is to look at the pattern that develops. If you notice, when I multiplied by 10, my product ended up being the original number with another 0 on the end. When I multiplied by 100, my product again started with the same number, and now I have 2 more zeros. And when I multiplied by 1,000, I ended up with the same number I started with, but with 3 more zeros. We definitely want students to notice the pattern when multiplying by powers of 10. So if I'm multiplying by 10, the product results in an extra 0 on the end. If I'm multiplying by 100, I see there's 2 extra zeros. If I'm multiplying by 1,000, I have 3 extra zeros on top of the original number. So as much as we want them to see that pattern, we do want to avoid telling the students to add a 0 to the end of the number to multiply. It's confusing to them when we say to add something when the problem is a multiplication problem. So we'd like to point out the pattern of the zeros at the end, but we avoid saying add a 0 to work this problem. We would prefer that they think of the digits on the place value chart all shifting one place to the left, which results in another 0 in the ones place. We can use a similar process to divide by powers of 10. So I start with 152 divided by 10. Again, if I think about my place value chart, when I divided by 10, I moved each digit one place value to the right. So my answer here, if you picture that place value chart, 2 ones moves one place to the right to the tenths place, 5 tens moves to the ones place, and 100 moves to the tens place. So 152 divided by 10 is 15 2/10. On the next problem, I'm shifting my digits 2 places to the right since I'm dividing by 100, and that's what we did on the place value chart in previous lessons. So now my 2 will end up in the hundredths place, my 5 will be in my tenths place, and my 1 will be in the 1 whole place. So I can see each digit move 2 places to the right. I'm dividing by 1,000 now, so here my 2 will end up in my thousandths place, my 5 ends up in the hundredths place, and the 1 ends up in the 10th place. Each digit moved 3 place values to the left, so the final answer is 0 and 152 thousandths. Again, we can look at the pattern that appears. If I'm dividing by 10, I'm moving each digit one place to the right. If I'm dividing by 100, I'm moving each digit 2 places to the right. And if I'm dividing by 1000, I'm moving each digit 3 places to the right. We want to avoid telling students to move the decimal point. A decimal point is a static mathematical symbol. It does not move. The digits move, so the digits change value, and that's why we see them move to the right when we divide by powers of 10.